Have you ever wanted better looking time lapses for your 3D prints? I wanted to move beyond the built-in printer camera and create high quality footage for my videos. So I picked up the Bambu Lab CyberBrick Timelapse Kit. In this video, I will show you how to set it up, the mistakes I made, how I got it working with my Sony ZV-E10 II, and whether it's actually worth buying. Hi, I'm Ralph from Crafting You, and today we're taking a look at the Bambu Lab CyberBrick Timelapse Kit. We'll cover the unboxing, assembly, setup, troubleshoot, and compare results from the printer camera, the iPad, and a Sony camera. The CyberBrick Timelapse Kit is a device designed specifically for Bambu Lab 3D printers that allows you to create professional looking time-lapse videos using external cameras. Instead of relying on the printer's built-in camera, the CyberBrick acts as a bridge between your printer and your chosen camera. Every time the printer reaches a predefined position during the print process, it sends a trigger signal to the CyberBrick, which then tells the camera to capture a photo. Over the course of a print, hundreds or even thousands of images can be captured and combined into smooth time-lapse videos. One of the things that makes the CyberBrick interesting is its flexibility. It supports Bluetooth shutter triggering for compatible phones, tablets, and cameras, wired shutter triggering for supported cameras, and even mechanical servo triggering for devices such as GoPros that require a physical button to be pressed. Let's start by taking a look at what's included in the CyberBrick Timelapse Kit. Inside the box, we get the expansion board and multifunctional core board. This provides Bluetooth Wi-Fi functionality, along with access to the I/O ports and power distribution for the kit. Next, we have the 4-pin and 6-pin interface connection. The 4-pin connection can be connected directly to a compatible printer, while the 6-pin connection can be used to daisy chain from an AMS unit. This provides both power and communication for the kit. Moving on to the USB-C port located on the core board, this can be used to supply 5-volt power, perform firmware updates, and connect compatible cameras for shutter control. I wasn't able to get this method to work with my setup, although this may be due to my particular camera rather than the CyberBrick kit itself. Next is the 2.5mm universal shutter cable interface. This allows you to connect compatible cameras that support external shutter release cable. Once connected, it's ready to use with minimal configuration. Finally, we have a multifunctional button, status indicator light, and a servo connection port. The servo connection port can be used to control action cams that require a physical button to be pressed, such as certain GoPro setups. The multifunction button can be used to manually trigger photos on connected devices, while the indicator provides information about Bluetooth connectivity and system status. Also included in the box are the BT2x6 self-tapping screws used to assemble the enclosure. These are the printed parts I decided to use. I printed them in black and green PLA with a sliding cover design. We'll take a closer look at the print files later on in the video, but here's what we have: the front housing, the rear housing, and the button. Yes, I printed the button in black. And yes, it will be printed in transparent and fixed. So feel free to call me a fool in the comments. And finally, we have the 6-pin cable that will be used to connect the CyberBrick to my AMS unit. Before printing anything, it's worth taking a look at the files Bambu provides through Maker's World. There are several different enclosures and mounting options available depending on how you plan to use the time-lapse kit. Whether you want quick access to the board, a cleaner finished look, or support for action cams, there's likely a design to suit your setup. The first option is a sliding cover enclosure, which is the version I decided to print. The cover simply slides open, giving quick access to the board and ports whenever you need them. If you're the sort of person who likes to tinker or experiment with different camera setups, this is probably the best option for you. There's also a fixed cover version available that gives the enclosure a slightly cleaner and more finished appearance. If you're planning to set the CyberBrick up once and leave it alone, this may be the best option for you. Next up is the button. Bambu recommend printing this in translucent filament for good reason. The status LED sits behind the button, so using a transparent material allows you to easily see the connection and status light information. There's also a magnetic mount option available. This allows you to attach the CyberBrick directly to your printer or any other metal surface. It's simple, but a useful addition if you want a cleaner install without relying on any adhesives. Finally, we have the servo shutter housing. This is designed for cameras that need a physical button press rather than an electronic shutter trigger. For example, some action cams and GoPro style devices can be controlled using a small servo motor that physically presses the shutter button. I won't be testing this setup today, but it's great to see Bambu providing options for different types of cameras. With the print files chosen, it was time to get everything onto the printer and start the building of the enclosure. With printing completed, here are the finished parts ready for assembly. Everything printed cleanly and was ready to go straight from the build plate, with the exception of the button, which I've already printed separately. Assembly starts by installing the button into the front housing. The button simply drops into place and becomes the interface for the status light and the manual shutter control. And yes, before anyone mentions it again, I know it should have been printed in transparent filament. Next comes the CyberBrick board itself. To install it, you need to slide the 2.5 shutter interface into position first, and once that's aligned correctly, the board drops neatly into place inside the housing, and everything fits together really nicely and feels well designed. With the board installed, the rear housing can now be fitted. The supplied self-tapping screws are then used to secure everything together. The entire assembly process takes only a few minutes and doesn't require any specialist tools. And that's the time-lapse kit fully assembled. You have access to the multifunction button for testing and manual triggering of connected devices. The sliding cover gives you quick access to the board when needed. Overall, the assembly was simple, straightforward, and probably the easiest part of the entire setup process. Now it's time to connect it to the printer and see what it can actually do. With the CyberBrick fully assembled, the next step is connecting it to the printer. For my setup, I'll be using the supplied 6-pin cable, which simply plugs into the side of the CyberBrick unit. The other end of the cable connects to an available 6-pin port on the rear of the AMS-HT. The single connection provides both communication and power to the time-lapse kit, so there's no need for separate power supplies. Once connected, the CyberBrick powers up and is ready to begin pairing with compatible devices. For my first test, I decided to keep things simple and use an iPad. Pairing is incredibly straightforward. Simply open the Bluetooth settings, look for BBL shutter, and tap connect. Once paired, the device will appear in your connected devices list and is ready to start receiving shutter commands. For my first subject, I used my skull test print, and here's the time-lapse footage captured using the H2D. This gives us an idea of the sort of smooth time-lapse effect we're aiming for. Now that we've seen what the H2D can do, here's a time-lapse captured using the CyberBrick Timelapse Kit from the same skull print on the H2D. The CyberBrick successfully triggered photos throughout the print and produced my first external camera time-lapse. Now let's talk about my camera mount. And by camera mount, I mean a ladder, a cardboard box, and 2 rolls of filament holding my iPad in place. This is peak engineering, and in the UK, we call this bodge it and leg it. It's not pretty, but definitely not permanent. But it does get the job done, and sometimes that's all that matters. While the iPad worked surprisingly well, I really wanted to see what sort of quality I could achieve using a dedicated camera. For this test, I'll be using my Sony ZV-E10 II. Getting the camera connected took a little more effort than expected. At first, my Sony wasn't showing up when I searched for Bluetooth devices. A bit of investigating, I found a dedicated pairing button on a time-lapse kit itself. Once I pressed the button, the camera was able to detect the BBL shutter device and connect it successfully. At this point, I also connected my iPhone 14 because I wanted to see whether the CyberBrick could maintain two Bluetooth connections at the same time, and everything connected successfully, which was a promising sign before moving on to capturing time lapses. Feeling pretty confident, I started my first proper test by printing a benchy and setting up the time lapse from above and from the front. At first, everything seemed to be working perfectly. Every time the CyberBrick triggered, the screen on the Sony looked like it was taking a photo. The problem was, when I checked the memory card afterwards, there was no photos at all. Meanwhile, the iPhone was happily capturing images without any issues. Something clearly wasn't right. The camera was using autofocus. Each time the CyberBrick sent a shutter command, the Sony was waiting for focus confirmation before taking the picture. After switching the camera to manual focus mode, I decided to test it by printing the Lunar Mooncat model. This time the camera triggered correctly and everything started working as expected. With the focus issue solved, I finally was able to capture a couple of time lapses. One camera was pointed above the printer, while the other was set up in front to get different perspectives. The only remaining issue was that I forgot to set the focus on the camera properly, and some of the footage wasn't as sharp as it could have been. And at one point, the tape I was using to hold the iPhone in place came loose, and the camera flew off the side of the printer. With the photos captured, the final step is turning them into a time-lapse video. For this, I'll be using DaVinci Resolve 21. The first step is simply dragging and dropping the captured images into the media pool. Because the photos are already numbered sequentially, Resolve keeps everything organized and ready for editing. Before creating the time-lapse, I like to take a quick check that all the images are in the correct order and I'm happy with what I've captured. Once I'm happy, everything looks right, I drag the photos onto the timeline. With all images selected, I right-click and choose Change Clip Duration. I experiment with a few different settings before settling mostly on one frame. With a selection running at 2 frames per image, this created a nice balance between smooth motion and a slower, more cinematic feel. As with most editing, there's no right way or wrong way, so feel free to experiment and find what works best for your footage. Once I'm happy with the results, it's time to export. I use a custom preset I've created for my 4K YouTube videos, which keeps things quick and consistent across all my projects. And with the time-lapse complete, what started as hundreds of individual photos has now become a smooth time-lapse sequence ready to be used in a video project. Like this. So after spending some time with the CyberBrick Timelapse Kit, what do I think? Overall, I'm impressed. The hardware is easy to assemble, setup is straightforward, and once I solved the autofocus issue on my Sony Cam, everything worked reliably. If you're happy with the standard printer time-lapse, you probably don't need this kit. But if you're creating YouTube videos, social media content, or simply wants a higher quality time-lapse, I really do think this is a worthwhile addition to your setup. If you've used the CyberBrick Timelapse Kit, let me know what camera you're using down in the comments. If you found this video helpful, don't forget to like, subscribe and ring the notification bell so you don't miss out on future reviews, projects here on Craft and Hue. And thanks for watching, and until next time, bye.